Okay, so profitability and gross margin analysis. Profitability is simply the difference, profit is the difference between revenue and costs. Total revenue and okay. It's the difference between revenue and costs, and there are two types of profits. We know that there is gross profit and net profit. Gross profit is simply the difference between total revenue and total variable costs.
Gross.
That's gross, yes. The net profit is the difference between total revenue and total costs. In economics, an abnormal profit is simply a profit. For them, they think it's abnormal to make profits. What is a profit? What is abnormal profit? Isn't it just making beyond what? Your buying price. Okay. We have gross profit. We are going to call it GP. We have net profit. I want us to understand this. Let's think of a commodity fertilizer. You have, hey, you want an S9? Let's think of phones, S9. You get the shop buys a phone at, let's say, 300,000, and then they sell it for 350. That difference is how much?
50,000.
50,000 profit. That is the what? Gross or net?
That is gross.
Yeah, that's the gross profit. So let's say on average, the shop is only dealing in that phone. They only sell that one phone. So let's say they sell, let's say 3 phones a day. How much is that?
The same phone, it's 150.
150k. And let's say that in a month, what do you get? Mm-hmm. 4.5 M.
Using price
150 times 30 is 4.5 M. So their gross profit is 4.5 M. But remember, this same business is paying rent of 1 M. Maybe it's employing 2 workers and paying them in total, including their lunch, also 1 M. And also, what else? Other costs, or maybe 500k. So what is their net profit?
The net profit is going to be 2 million.
Okay, so it's this 4.5 minus 2.5, which gives us 2 million. So how did we get the gross profit?
Which profit?
The gross profit.
The gross profit was just...
Okay, let's start. How many phones did they sell in total?
No, per day. Per day they sell 3.
So 90 phones in a month. And he was buying the 90 phones total at how much?
90 times 300.
7. So he bought phones worth 27 M, and he sold them at 350. What did he get? 90 phones times 350. Do the math. 31.5 M. So he bought phones in total at 27 million. That is at 300k. At 300, he bought 90 phones at 300,000 each, which gives you 27 million, and sold each of those 90 phones at what? 350,000, which gives you 31.5 million. So his gross profit was 4.5 million, right? Which was the difference between total revenue minus total variable costs. These are variable costs, total variable costs. This is the total revenue. You understand that? Now, at the end of the time, he had expenses. He had labor, he had rent, and he had other expenses like rubbish, lighting, electricity, and all that. So 2.5. So you find that this business, though although it looked like it was making a gross profit of what? 4.5. His actual net profit was only 2 million. That's basically the type of profit. So profitability is consistent positive difference between revenue and costs. And we look at two things: efficiency and effectiveness. Efficiency is what? How do you understand efficiency?
Like using
Limited resources. Using the limited resources to achieve the highest
output.
So efficiency is just a relationship between the input and output. So you want to use the least resources to achieve the highest output, meaning you have the what? High efficiency. Low inputs, high outputs gives you high efficiency. So efficiency is using least resources to produce maximum output. Then effectiveness is just doing the right thing well and time. Now let's look at gross margin. We're now going to look at those things one by one, those terms. We are going to begin with gross margin. Gross margin, what is margin? It's simply, in this case, what was our gross margin? How do we get it? How do we calculate?
gross margin.
In the example I gave,
So it's total revenue minus total cost.
total variable cost. So total revenue minus total variable cost. And in this case, our total revenue was 31.5 M. 0.5 M minus 27 M. So our gross margin was 4 million. Is that right?
4.5.
Sorry, you're right. 4.5 million. Now, that is gross margin. We have said gross margin is simply total revenue minus total variable cost. Now, what is gross margin ratio? What is that? So gross margin ratio, what is gross margin ratio?
I'm just trying.
Yes?
Is it total revenue out of total cost times 100?
Total revenue by total cost times
Total
100, no?
variable cost.
Gross margin. Supposed to be.
It is your gross margin. Now you express it as a ratio of your what? Of your total revenue.
So it's the gross margin
Yeah?
out of total revenue
Yeah?
times 100.
Yeah. Place. So what do you, so in this case, it was 4.5, calculate.
4.5.
31.5, yeah?
That's when you're telling us that we don't put the percentage, the thing of percentage.
So when we get 4.5 divided by 31.5 we times 100, we get 14.29%. So this business was making a gross profit of 14.29%. That's it. So they hired this figure, they hired the profitability. You want this to be high, 50 to even 90%, if possible. Now, like service businesses, someone comes to a salon, they only apply some little oil and they pay 50K.
Hello.
So that's like 90%. Now we look at types of costs. We have the variable costs, we have the fixed costs. In our example, the variable cost was only one, it was stock. But then there were fixed costs, which was rent, labor, and others, which included electricity. Let's call it electricity, let's not use vague things. So a variable cost is one which affects is one which changes with what? The level of output. So if you sell more phones, if you buy and sell more phones, your what? Variable costs are higher. Fixed costs for them, whether you sell no phone or you sell 1 million phones, the rent remains the same, the labor remains the same, the electricity remains the same. All right. That is it for the types of costs. So they vary with output, variable costs, inputs do not vary. Examples: depreciation, taxes, interest, insurance, salaried labor. Then variable, we have seeds, fertilizer, labor, fuel, repairs. Now we have the total costs. Total costs, which is simply total variable costs plus total fixed costs. And here we have an example. an enterprise dealing in cotton, their yield is this, and the value of their yield is this. And with that, we can get the variable cost is given, gross margin, blah blah. Now, input-output decision. Now, as a business, you want to now know when should I continue. Input-output decision is simply more of efficiency. Like what we said, efficiency is just a relationship in what you get for what you put in. So input-output decision, we are now coming up with a formula to measure this. And we have two variables. We say if I put in X, I get given number of Y. I will get given number of Y if I put in a given number of X. So our Y, which is our output, is a function of our X, which is our input, right? So there is this relationship between output and input. That is the production function, the technical relationship between inputs used and outputs used. For example, for every 10K I put in my business, I get 60K. That's an example. For every maybe 10 bags of fertilizer, I get extra this number. That is it. And there are terms we talk of. The first one is the total physical product. Actually, that word physical just to confuse you. Total product. If I say total product, what do you think of? Total output. So total physical product is the total output. Then the next one we look at is the average product or average physical product. When I say average physical product, what am I doing? I'm looking at the relationship between my total product divided by my inputs. So on average physical product is the total physical product divided by a quantity of inputs, which is X. Meaning that, in our example, if our total product was 60 and this one was 10, so you get 6. On average, you get 6 times more compared to what you put in. Or maybe if this was bags and this was yield, so maybe you get 6 bags of yield for every bag of fertilizer you put in. That is average physical product. Now, we look at marginal physical product. Marginal physical product is similar to this, but only that we are talking of additional. So it is simply the additional average physical product, which is for every addition, it's simply the additional what? Total physical product you get for additional inputs. Are we together?
Yes.
So we are going to use this to understand something important. Let me see, how do I describe it? Total physical product is simply your total output. Then average physical product is simply the difference between the ratio of total physical product to inputs. That relationship on average. On average, for every 10K I put in, I get 60K. Then marginal physical product is for addition. If I add 10K, I'll end up getting maybe 40, 50, 60 or 70K. That is what? Marginal physical product. These two, you should be able to distinguish these two. Average in your head, you should be able to tell average and what? Marginal, because we are going to be comparing them. We shall start with a scenario where the marginal physical product is greater than average physical product. What do you understand by that relationship? In terms of, we are going to be looking at in terms of returns.
In terms of return, when the marginal physical product is greater than the...
Meaning that if I add one more unit of inputs, I will get more than what I have been getting before on average. Does that statement make sense? Marginal physical product being greater than average physical product means if before 10 bags of fertilizer was giving me 60 bags of yield, if I put in the 10 bags now, I expect to get more than 60, maybe 70 bags of yield. So in this case, the marginal physical product is greater than average physical product. Then let me use a curve to illustrate this. So we have here 10. Maybe 4 months. Let's use something simple. One bag to give you here. One bag, if before 1 bag of fertilizer was giving you 5 bags of yield, but now 1 bag is giving you 7. If you add, we are going to try to illustrate that. So we have our 1, 2, 3, 4, 5. 1, 2. So we have here 5, 10, 15, and 20. We have here 0, and we have 1, 2, 3, 4, 5. So at first, the first bag was giving us 5, isn't it? The second bag I do maybe gives us extra 7. The third bag I do maybe gives us extra 8. Like that. So you end up with a curve which is sort of going up like that. That is when the marginal physical product is greater than the what? Average physical product. Meaning that before, on average, I was getting 5 bags of yield for every bag of fertilizer I add. But now, if I add again another bag, I end up getting 7 bags of yield. That is add. When I say add, that's marginal. Now, the second scenario, we have the marginal physical product being less than the average physical product. You notice that in both cases, the upper one and this one, they are both positive. Marginal physical product is positive and average physical product is positive. So here, maybe at first 1 bag was giving me 5, right? Then suddenly 1 bag is giving me 4. You get that? If we are to illustrate that, One, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. So 5, 10, 15, 20, 25, 30, 35, 0, 0. So the first bag was giving me 5, isn't it? The second bag is giving me 4. The third bag is too small. It's hard to see it. One, 2, 3, 10, 20, 30. Same thing. 5, 10, 15. The first bag was giving me 5, right? The second bag was giving me 4. So count 4, we end up here. The third bag is giving me 3, we end up here. So you end up with a curve which is like that. It is still an increasing curve, but it's diminishing. The additional increase is less, diminishing. This is an exponential curve, meaning that increasing returns. At first it gives me 5, gives me 6, 7, 8, 9, like that. Something like this is what we expect. And now there's a point still with the marginal physical product being greater than average physical product. We reach a point where the marginal physical product is negative. It keeps reducing until a point whereby it's negative. Discover this.
When the marginal physical product is greater than
Sorry, this is less. When the marginal physical product is less than the average physical product, the first stage is this one. But then there's a point it reaches and it is now reducing negative. Meaning that if you add more fertilizer, the yield keeps dropping. So that gives us the 3 stages. That is first increasing, then flatline, then declines. So this first stage, here the marginal physical product is greater than the marginal physical product is greater than average physical product, right? Then here, all this region, the marginal physical product is greater than the average physical product. But at this point, the marginal is negative. Here, the marginal is positive. That is what brings about this curve. Okay, so the 3 stages. The first stage is the stage of increasing returns. The total product rises rapidly. So this is the area under is the total product, if I'm not mistaken. It rises rapidly. Then at this stage, the marginal product or marginal physical product is greater than the average physical product. You can clearly see that. Then the second stage is the stage of diminishing returns. AP and ME decline but positive. So the marginal physical product and average physical product are declining but positive. This is optimal zone. This is why you should operate in somewhere in between here. But then there is the third stage of negative return where the total physical product declines, marginal physical product is negative or less than 0. And this is the point where you should not reach, you should not cross this line. So you should work between these 2 lines, whereby the returns are diminishing, but they're still there. Once you cannot get negative returns, no longer makes sense to continue adding inputs. So optimal input use or marginal analysis principle. For you to maximize profits, this is what we're saying. The marginal returns must be equal to the marginal cost. For you to maximize profit, the marginal revenue, the additional revenue must be equal to the marginal costs. This is input output, right? Input output. And input, you can talk of that as costs, and output as revenue, right? So you want to reach a point until when they are equal. That's where you stop. Marginal value product must be equal to the marginal input cost. Marginal value product must be equal to the marginal input cost. This is the value of the additional product. Remember, at first we were talking of in terms of bags of fertilizer and then yield. Now the yield, the marginal input cost, maybe 1 bag of fertilizer is 100k. Then the marginal value product, we say that marginal physical product, let's say it is 5 bags, and we know each bag is maybe 100k. So this is 500k. So you want to continue. If you want to maximize profits, you have to reach a point until the marginal physical product, MPC, is equal to 1. At that point, our marginal input cost will be equal to the marginal value product. Because when it's 1, that means it's at 100k. Meaning that 100k worth of fertilizer in addition gives you 100k worth of yield. That is a point whereby you maximize profits. And the simple math is that if you find that your marginal value product, this one here, is now here in this case, is greater than the what? The marginal input cost, continue adding inputs until they become equal. Don't cross to negative. So the point of economic optimum is when profits are maximized. That means the marginal revenue equals the marginal cost. The point of technical efficiency where total output is maximized. Next, we're going to look at the break-even analysis. And we are going to try to derive the break-even equation. So we are trying to derive the break-even equation. Break-even quantity, sorry. Break-even quantity. We know that for you to break even, what should be true? Total revenue must be equal to the total costs. We know that our total revenue is sales, which is simply the price times quantity. And we know that our total cost is the same as total fixed costs plus total variable costs. So total fixed costs. And how can we express variable costs in terms of quantity?
In terms of quantity.
Total variable cost is equals to unit cost, which we are going to call variable cost per unit, times quantity. So variable cost, let me first write this to you well. Total fixed cost plus variable cost per unit times quantity. This together is the same as what? Total fixed cost. Let me start fresh. We know that for break even, your total revenue must be equal to your total costs. True or false? And we know that our total cost can be expanded to give us total fixed costs plus total variable costs, right? We know that total revenue and total variable costs can be expressed in terms of quantity. Because total revenue is just simply the sales, the amount you get after selling, which is simply the price times the quantity, which is equals to total fixed costs plus our total variable cost is also can be got. If we know the cost of one phone, we can get the total cost of all the phones, which is the cost of one phone, which we are calling variable cost per unit VC, times the quantity of phones, this. Remember, we are finding break-even quantity, which is this Q. So we have to bring Q this side. So we end up with P times Q minus VC times Q being equal to the total fixed costs, right? So Q is common, we pull out Q. What do we remain with? P minus VC equals total fixed costs. Therefore, if we have to make Q the subject, we end up with total fixed costs divided by. Does it look like this? That is it. And there are questions, I won't go into them, we don't have the time. Okay, next. Yes?
I'm tired.
You're tired?